Hi, I'm Freddy from Singapore, and today I will be sharing with you about the paradox of calculus. It will be mostly on the paradox of calculus. So, what exactly is the paradox of calculus? So, in the past, some mathematicians have proven that um, through calculus, 1 equal to 2 or 1 equal to 0, which is wrong, but in a way that they prove it, many people actually trusted their method and believed that 1 equal to 2 and 1 equal to 0, even though it contradicts their belief. And even just simple calculation or simple uh, evaluation, this is just wrong. But look at the method that they do it, and you think that it is actually correct. So now I'm going to be doing the first paradox where 1 is actually equal to 2. So let's assume that the original equation y equal fx is y equal x squared. This paradox y equal 2 is based on differentiation of x squared. So x squared, it means I have x numbers of x. So it would be correct if I put it like this: x plus x plus x plus continuous number of x, and there are x number of x here. So if I differentiate this, I will have to differentiate this. And so and so. And from here, if I differentiate this, I'll use power rule, bring down the power, and my power minus 1 will be 2x. For this side, since it's just x, differentiating of x, I will get 1. So I have 1 plus 1 plus 1 plus dot 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 plus 1. And since there's x number of x here, there will be x number of 1 here, which will lead to us having this. So x1 and 2x. Now, when mathematicians make this proof, they assume that x cannot be 0. So, it is correct, technically correct, to divide x throughout. So, at the end result, we get 2 equal to 1, which is wrong. Now, where is the mistake then? Everything here flows correctly, but yet they're wrong. Well, the mistake lies in this part. The middle of these two parts, something is wrong. But you see, x squared can be seen as x plus dot 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 plus x, but it can also be seen as x times of x. You see, if you compare this and compare this, you can see something is missing. If I differentiate x squared, I'll get 2x, the same. But if I differentiate this, for this part we have to use product rule, and I'll differentiate, then I will copy this, and I'll differentiate outside. So apparently, this part is present, and yet this part is missing from here, which is exactly why they had led to the mistake of concluding that 2 equal to 1. And this actually solves the first paradox, 1 equal to 2. So now I'll be doing the paradox of 1 equal to 0. So just now, the method of 1 equal to 2 was proved by differentiation. So now this paradox will be proved by integration. So a short recap: if I integrate f prime x, I will get back my original function and an arbitrary constant. So this time, let my f prime x be equal to 1 over x. So a quick recap is, if I integrate 1 over x, I will get ln modulus x and an arbitrary constant behind. But what if I want to do integration by parts? So I will split them into 1, integrate of 1 multiplied by 1 over x dx. So now whenever we do integration by parts, we always have to follow this method. This is a method. So it is this. The acronym is LIATE. The L stands for logarithm, I stands for inverse trigonometry, A stands for algebra, T stands for trigonometry, and E stands for exponential. So as we go down the list, the ease of integrating actually increases. However, if we go up the list, the ease of differentiating gets easier and easier. So now in this case, 1, we consider it as an algebra. 1 over x is definitely an algebra. So which one should we integrate actually? Now in this expression here, we integrated 1 over x. So there's absolutely no point if we integrate 1 over x. So now we integrate 1 and differentiate 1 over x. So if we integrate 1, we get x, and then we will copy 1 over x, we'll minus x, and we differentiate 1 over x. Alright? Bring the minus sign out. So x multiplied by 1 over x, we get 1. Minus sign come up, I'll put plus x over x squared. It will be 1 over x. So you see, this and this is actually the same. So I'll be able to cancel them. And now I'll be left with this equation. 1 equal to 0. But where actually is the mistake? The mistake actually lies at this part. You see, from here, I did not add something that's important, but instead I say it's the arbitrary constant. Here, also the arbitrary constant. In this case, what is missing from this whole statement is essentially this, the arbitrary constant. So, by putting this arbitrary constant, we are actually clarifying the whole statement, making it correct. So I'll be putting this. C plus 1 actually equals 0. Therefore, C is actually negative 1. And with this being negative 1 minus 1 against 0, this term will actually equal to this term. Therefore, this proof is actually wrong. And therefore, the paradox of 1 equals 0 is solved. Of course, there's an alternative method, which is to use definite integral. And if we use definite integral for a constant, it will be 0, and this will automatically equal to this. So now I'll be doing the conclusion of the paradox of calculus. So recapping, just now 1 equal to 2, the mistake is that we actually differentiate once and we only differentiate this. And as a result, we get this, which is wrong. And that is why we end up with 1 equal to 2. As for just now the example, where 1 equal to 0, we've forgotten the arbitrary constant, which is very important, because this arbitrary constant can prevent such a paradox from happening. And with this, I conclude my sharing on the paradox on calculus, and hope my sharing has benefited you.